Ever wondered how the body's aging process is influenced by aspects like insulin resistance and cellular senescence? Welcome to the Victory Education Lounge. I'm your host, Maurice, and today we're diving into a fascinating topic: insulin resistance and cellular senescence. This is part 65 of our ongoing series on health and wellness. Before we begin, please take a moment to like this video, subscribe to our channel, and leave a comment sharing your thoughts or experiences. Your engagement helps us reach more people with this valuable information. Today, we're delving deep into the world of cellular biology to understand how insulin resistance and cellular senescence play a pivotal role in aging and age-related diseases. Let's break it down. Insulin resistance is a scenario where cells in your body start to respond less efficiently to the hormone insulin. On the flip side, cellular senescence is the process where cells halt their division and enter a permanent state of growth arrest. Though these processes may seem quite distinct, they are actually interconnected in ways that greatly impact our health and longevity. From oxidative stress to inflammation, telomere shortening to mitochondrial dysfunction, these two biological phenomena share a complex relationship that we're about to unravel. So, buckle up and let's dive into the 10 ways these two processes are interconnected. The first connection is oxidative stress. This is a process where our bodies produce free radicals, unstable molecules that can harm cells. Both insulin resistance and cellular senescence can be triggered by this oxidative stress, creating a harmful cycle where one condition exacerbates the other. Next, we have inflammation. When your body is insulin resistant, it leads to chronic low-grade inflammation, a state where your body is constantly in defense mode. This, in turn, can induce cellular senescence, leading to an accumulation of aged cells that can't function properly. Our third point is telomere shortening. Telomeres are the protective caps at the end of our DNA strands, and they naturally shorten as we age. However, insulin resistance can accelerate this process, bringing about cellular senescence faster than usual. Then, there's mitochondrial dysfunction. The mitochondria are the powerhouses of our cells, providing them with the energy they need to function. Both insulin resistance and cellular senescence are associated with impaired mitochondrial function, leading to reduced energy production, further worsening the state of our cells. Finally, let's talk about DNA damage. Our DNA is constantly under threat from various factors, including oxidative stress and inflammation. Insulin resistance can increase this DNA damage, acting as a primary trigger for cellular senescence. With more DNA damage, cells are more likely to enter a state of permanent growth arrest, contributing to the aging process and the development of age-related diseases. So, we've covered oxidative stress, inflammation, telomere shortening, mitochondrial dysfunction, and DNA damage. Each of these factors intertwines insulin resistance and cellular senescence, creating a complex web of interactions that impact our health and well-being. This brings us halfway through our list. As we continue to unravel these connections, we'll gain a deeper understanding of how our bodies age and what we can do to maintain our health and vitality for as long as possible. Now let's move to the sixth point: impaired autophagy. Autophagy, or the cell's cleaning process, can be disrupted by both insulin resistance and cellular senescence. This impairment can lead to an accumulation of damaged proteins and organelles, potentially exacerbating both conditions. Next up is altered nutrient sensing. Insulin resistance has a direct impact on nutrient-sensing pathways, which play a critical role in regulating cellular senescence. When these pathways are disrupted, it can speed up the process of cellular aging. Our eighth point is stem cell exhaustion. Insulin resistance can lead to premature stem cell exhaustion, which accelerates the accumulation of senescent cells in our bodies. This can further contribute to aging and the development of age-related diseases. Moving forward, we have epigenetic changes. Both insulin resistance and cellular senescence are associated with epigenetic alterations, changes that affect gene expression without altering the DNA sequence itself. These alterations can affect cellular function and contribute to the progression of both conditions. Lastly, we have the senescence-associated secretory phenotype, or SASP. Senescent cells release inflammatory factors known as SASP, which can exacerbate insulin resistance. This creates a feedback loop where insulin resistance and cellular senescence can perpetuate each other. So, to sum it up, insulin resistance and cellular senescence are deeply intertwined, each influencing and amplifying the other through mechanisms like oxidative stress, inflammation, telomere shortening, mitochondrial dysfunction, DNA damage, impaired autophagy. altered nutrient sensing, stem cell exhaustion, epigenetic changes, and the release of inflammatory factors by senescent cells. Understanding these connections provides us with a clearer picture of the complex process of aging and the development of age-related diseases. Now that we've established the connections, let's look at some solutions. One of the most effective strategies is caloric restriction. Caloric restriction. It's a term that might sound intimidating, but it simply means reducing your daily calorie intake without compromising on essential nutrients. This moderate reduction in calories can improve insulin sensitivity and reduce cellular senescence. How does this work? Well, when you consume fewer calories, your body needs less insulin to regulate blood sugar levels. At the same time, reduced calorie intake can lower the metabolic burden on cells, slowing down the rate at which they become senescent. The potential upside? A longer, healthier lifespan. But there's a catch. Caloric restriction can be challenging to maintain over the long term, leading to potential nutrient deficiencies if not carefully managed. So it's always best to consult with a healthcare professional before embarking on this journey. Next on our list is regular exercise. The benefits of physical activity are multifaceted, but let's focus on its role in managing insulin resistance and cellular senescence. Regular exercise improves insulin sensitivity. In other words, it makes your body more responsive to insulin, ensuring that glucose is efficiently transported from your bloodstream into your cells. This can help prevent the development of insulin resistance. But the benefits don't stop there. Exercise also stimulates the body's natural process of autophagy, or cellular cleaning. This process helps clear out senescent cells, reducing their accumulation and the negative effects associated with it. The pros? Exercise benefits your overall health, not just your insulin response and cell aging. The cons? It requires a consistent effort and time commitment. But remember, every bit counts, so even small increases in activity can make a big difference. These are just a couple of ways you can manage and prevent insulin resistance and cellular senescence. Remember, the goal here is not to completely eliminate these processes, but to manage them in a way that supports our overall health and longevity. Stay tuned for more strategies in our next segment. Moving on to our third strategy, intermittent fasting. Intermittent fasting is an eating pattern where you cycle between periods of eating and fasting. It may improve insulin sensitivity and promote autophagy, the cell's natural recycling process. The pros: it can be highly effective for some people. The cons: it may not be suitable for everyone, especially those with certain medical conditions. Always consult with a healthcare professional before starting a new diet regimen. Next, let's talk about an antioxidant-rich diet. Foods high in antioxidants, such as berries, dark chocolate, and kale, can help combat oxidative stress, one of the primary triggers for both insulin resistance and cellular senescence. The pros: it's a natural and generally safe strategy. The cons: it may not be sufficient alone for severe cases, and it's always a good idea to pair it with other lifestyle changes. Last but not least, we have stress management. Chronic stress can contribute to both insulin resistance and cellular senescence. Techniques to manage stress include meditation, yoga, deep breathing exercises, or simply enjoying a favorite hobby. The pros: these techniques can be easily incorporated into your daily routine and can have a myriad of other health benefits. The cons: stress management alone may not be enough to reverse insulin resistance or reduce cellular senescence, but it's certainly a piece of the puzzle. Remember, these strategies are not quick fixes. They require consistent effort and, in some cases, significant lifestyle changes. But don't be discouraged. Every small step you take towards a healthier lifestyle can have a profound impact on your overall well-being. Also, keep in mind that everyone is unique. What works for one person may not work for another. It's essential to listen to your body and consult with a healthcare professional to determine the best strategies for you. These strategies are not just beneficial for combating insulin resistance and cellular senescence, but also for your overall health. So that's a wrap on the 10 ways insulin resistance and cellular senescence are interconnected. We've journeyed through the complex pathways of our body's biology, uncovering how these two processes influence each other and our overall health. From oxidative stress to inflammation, telomere shortening to mitochondrial dysfunction, and DNA damage to impaired autophagy, the connections are both intricate and profound. We also discussed how managing these processes can be achieved through strategies such as caloric restriction, regular exercise, intermittent fasting, an antioxidant-rich diet, and effective stress management. Each of these strategies offers its own set of pros and cons, but the key takeaway is that a holistic, balanced approach is essential. As we wrap up, I want to emphasize the importance of understanding the interconnected nature of our body's processes. By recognizing how insulin resistance and cellular senescence influence each other, we can take a more holistic approach to healthy aging and disease prevention. Before we conclude, I must provide a brief disclaimer. The information in this video is for educational and entertainment purposes only. Any health-related decisions should be discussed with a licensed physician. Your individual situation may require specific medical attention, and it's crucial to seek professional advice for personalized care. Thank you for joining me in the Victory Education Lounge. If you found this information helpful, please remember to like, subscribe, and share your thoughts in the comments. Your experiences and questions can help others on their health journey. Until next time, this is Maurice wishing you health, vitality, and youthful cells.